This is section 3 of chapter 1 on linear and quadratic functions. And this is actually going to be part 1 on just the linear functions. Okay, so we want to talk about linear equations. So a linear equation is an equation in two variables, and it can be written in standard form, although that's not generally the most user-friendly of these. So in standard form, it's going to be ax plus by equals c. So it is important to note that both x and y are to the first power. They can't be like to the 1/2 power or to the third power or anything like that. Can't both be 0. X and y are both variables, and so this is the standard form. Okay, and when we start talking about lines, slope is a really important part of that. Okay, so the slope of the line, you should be familiar with the y2 minus y1 over x2 minus x1, or the rise over run, or you may have even seen it, the change in the y's over the change in the x's. All of that's an indication of rise over run, which is the slope. Okay, so you should be able to calculate the slope of a line through 2 points, but we'll go through an example here. So our slope we just looked at is y2 minus y1 over x2 minus x1. So our first point, and it doesn't matter which one you consider to be the first and which one the second, you just need to be consistent. Okay, so if I'm going to plug into this, I'll have y2 will be first, so 5 minus 6 over -1 minus 2. So I'm going to end up with -1 over -3. And we know that a negative divided by a negative is in fact a positive. So basically our slope is 1 over 3. So for every 1 unit that I rise, I'm going to run 3 units. Okay, so it has a positive slope. So positive slope means it does in fact rise from left to right. If you have a negative slope, it falls from left to right. A horizontal line actually has a slope of 0. Okay, so it doesn't have it actually has a slope of the numerical value 0. A vertical line has a slope that is not defined. Okay, mainly because when you do that calculation, you end up with 0 in the denominator, and if you remember, when we have 0 in the denominator, it is not defined. Okay, there's different forms of lines. We talked a bit about standard form, although it's not, like I said, the most user-friendly. These are the two that I would say we're going to focus on most: slope-intercept form and point-slope form. And in fact, I'm going to use slope-intercept form the most, but it doesn't mean that you can't use point-slope form. If you've learned how to use that and you prefer to use it, then go for it. That's fine. Okay, so a horizontal line is always y equals the y coordinate, and vertical line is always x equals the x coordinate. Okay, if you're asked to work with your intercepts, just remember that the intercepts are where it touches the x-axis or the y-axis. So you're just going to be replacing one of your coordinates with the 0 as appropriate for that, and then work with it like a regular point. Okay, so on this example, we've got a line with a slope of 3. So our slope is generally denoted with the letter m. So we've got m is 3 and passes through the point 2,5. So that's our x and our y. And we want to find the equation of the line. This is asking for all the forms. As long as you can put it in one form, that's fine. So I'm going to actually look at both point slope and slope intercept just so you can see the difference. So for slope-intercept, okay, slope-intercept is y equals mx plus b. Okay, so we've been given the m, the x, and the y. So all we're going to do is we're going to plug into this, and we're going to find the b. Okay, so that's going to be y is 5, m is 3, x is 2, and then we want to find the b. Okay, so we'll do the algebra here. 3 times 2 is 6. we subtract the 6, we're going to see that b is -1. Okay, and it's asking for the actual equation of the line, not just the b. So we're going to write it back, except we're going to substitute for the m and for the b. So m is going to be 3, and then we'll have our x, and then in the place of the b, I'll put -1. So that's our equation that goes through this point with this slope. Now, if I want to do this with point slope form, okay, point slope form looks like this: y minus y1 equals m times x minus x sub 1. Okay, so this would then be your x sub 1 and your y sub 1. So on this one, you don't substitute for the y and the x, you substitute for the subscripted ones. Okay, so that would be y minus 5 is equal to 3 times x minus 2. And it's okay to leave it like that. The problem is if you're asked to graph, this is an easier form to graph from. And so I would say it's better if you leave it in slope-intercept form, even if you start with point slope, which is not hard to do. Just distribute the 3 and then add the 5 to both sides, and you'll have the exact same answer. So I have no preference which one you choose to do. It's just you do need to be able to do at least one of the ways. Okay, this is one you can practice. Okay, so m would be -3. This will be the x and the y. And like I said, I generally prefer slope-intercept form, so that's what I'm going to go for here. My y is 10, m is -3, x is -2. I need to find the b. Okay, so b is going to be 4. So I'll have y equals -3x plus 4. Okay, so these are linear functions, and a linear function, like we said, just has x and y to the first power, and you can always think of you could replace the y with the f of x because we've talked about function notation. So that's also a way to look at that. Okay, this one, you may be asked to do different things with these equations here. So this first one asks you to put it in to graph the equation, okay? So anytime you're asked to graph the equation, I would say you want to use slope-intercept form. So we want to put this in slope-intercept form. So I'm going to solve this for y. If I solve it for y, that's going to have it in slope-intercept form. Okay. So if I'm solving this for y, I'm going to move the 4x to the right side. So it's going to go from a positive to a negative when I move it. And then I want the y by itself, so I'm going to divide by -3. So I'll have y equals, and for the purpose of graphing, I would say that it is better to go ahead and simplify these. So you want to do what I sometimes refer to as the bunny ears. So you want to put both parts over the -3. So it'll be -4 over -3 with the x, and then 12 over -3 would be -4. And we want to go ahead and simplify those two negatives and make it a positive. Okay, so this would be our equation here. And if we look at the graph of that, our equation for that one is y equals 4/3 x minus 4. So we would start down here at -4 and we'll go rise 4, run 3, and you find your other intercept there. Okay, so kind of applying the linear function modeling to a business example. We have a student organization is planning an event and intends to sell custom printed t-shirts. The t-shirt committee found a company that will create the artwork for the shirts for a fee of $175. The company will print the shirts in various sizes for $4.75 per shirt. The organization plans to sell the shirts for $12 per shirt. Okay, so looking at this, we want to write a function that gives the total cost for printing the shirts based on the number of shirts printed. So we've got two costs. One is the $175. So that's a fixed cost where they set up the equipment to print the shirts. That's the base charge for doing that. And then we have this per shirt cost. So this is the variable cost. So when I'm writing this, I'm going to use my notation for the cost, and then I'm going to do the fixed cost plus the variable cost. Okay, so for my fixed cost is the $175, and then the variable cost, the per shirt cost, is 475x, because it's not just 475. We don't pay that one time. We pay it for every shirt that that company prints for us. So we've got to multiply it by the number of shirts we're going to sell. So this would be the function for the total cost for. So we have the total cost function, but we also need to find the revenue function. So the revenue function is always x times p, or you can think of it as p of x. It really just depends. So x is going to stay there as our variable, and then the price that we're selling each one of the shirts for is the $12 per shirt. So we're going to multiply each one by multiply the x by 12, and we're going to get 12x, and that's going to be our revenue equation. All right, and then find the number of shirts the organization must sell in order to break even. Okay, so break even is when the revenue is equal to the cost. Okay, so we found the revenue equation, we found the cost equation, so we need to set this to equal to each other. So our cost, we said the revenue was 12x, and our cost function was 175 plus 4.75x. So we just need to combine the x's together. So we'll have 12x minus 4.75x is equal to 175. That's going to give me 7.25x is equal to 175. We'll divide by the 7.25, and we're going to find that x is 24.14. So we obviously can't produce 0.14 of a shirt. So we're going to say approximately 24 shirts is what's going to give us our break-even point. So if we sell less than 24 shirts, we're actually going to be losing money. So we want to be able to maximize that profit by selling at least more than 24 shirts. Okay, we've talked a little bit about interval notation, but that is included in this section, like officially. So we'll talk for just a minute about that. We've got different, you've got your inequality notation and your interval notation. Unless it specifies which one to use, I'm fine with either. But looking at this, anytime you've got like the A being included with that line underneath, then you're going to have the brackets on that. But if you don't have the line, then you have the parentheses, and there can be all the different combinations of those. Infinity always gets a parenthesis, and that's kind of the main things there. Okay, so like on this one, if we want to write it in interval notation, the first thing I would do with this is turn it around. Because generally we like to go from left to right, and 5 is more than 3. So I'm going to turn it around, just make sure that it's always still pointing to what it's supposed to point to. So I'll have less than x and then less than or equal to 5. So that's just kind of taking and turning that whole thing around so that my smaller number is first. So then when I put it in interval notation, it's everything between 3 and 5, not including the 3, but including the 5. So the 3 didn't have the line, so it gets a parenthesis, and the 5 did have it, so it gets a bracket. Okay, this one we're supposed to write it in inequality notation. So this is saying everything from negative infinity to 4, or another way to say that is x is less than or equal to 4. Okay, it's equal because of the bracket, And it's less than because you're talking about coming from negative infinity to 4 and then stopping at 4. Okay, this one, if I was writing it in inequality notation, this first part, I would say x is less than or equal to -2. And then here I would say x is greater than or equal to +2. And again, we put the equal part because we've got the brackets. Or represents, actually, that's the intersection, so I should have put and here. And then the last part, putting it in interval notation, that's going to be from negative infinity to -12. And -12 does not get a bracket because it's not included.